Go.
All right, let's move on to lesson 57, ideal gas laws. This is another chemistry lesson. This is mostly using ratios in order to solve chemistry problems. So hopefully when you hit chemistry, you'll remember this and this will help you out. We're going to use ratio problems and we're going to use the general ideal gas law equation, which is right here, P1V1 over T1 equals P2V2 over T2. The letters stand for P stands for pressure, V stands for volume, T stands for temperature. Pressure is measured either in newtons per meter seconds, which you won't understand yet, so just use it. And A is for atmosphere. So pressure can be either of these ways. And I just remember the Talon wrote on the board.
Hey.
All right, so volume is measured either in liters, milliliters, or centimeters cubed, and temperature is measured in kelvins. All this will come clear to you when you take chemistry. So let's look at an example of how we use the ideal gas law equation to solve this chemistry problem. The problem is 4 liters of an ideal gas at a temperature of 800 Kelvin had a pressure of 100 newtons per meter. If the volume was increased to 1 to 10 liters and the temperature reduced to 600 kelvins, what would the pressure be? So what we have to do is extrapolate out of this word problem what we need to fill in this equation. It's real simple. This is not difficult. It's not like the distance problems. These are simple ones. So we start out with our volume 1. It tells us it's 4 liters. And liters, volumes is in liters, so we know that's volume. At a temperature of 800 Kelvin. So we know our temperature 1 is 800. Had a pressure of 100 newtons per meter seconds. So they tell us everything. Our pressure is 100. If the volume was increased to 10 liters, so our volume 2 is 10 liters, our temperature was increased to 600 kelvins, what would be the pressure? So that's what we don't know. This is kind of like freeing the variable. So we're going to fill in everything that we know and free the variable. So our pressure 1 is 100. Our volume 1 is 4. Our temperature 1 is 800. Equals our pressure 2. This should be P2 right here. Our pressure 2 we don't know, so we'll just leave that as P. Our volume 2 is 10, and our temperature 2 is 600. So once we get that in the equation, then we just need to solve it for P. Make sure I got all that right. So this is going to be 400 over 800, so I'm just going to reduce that to 1 over 2. And I can reduce this one. 10 goes into 660 times. If you can reduce your ratios, it makes doing the problem a lot easier. So we just cross multiply. We get pressure equals, if I cross multiply, it would be 2P equals 60. And so we get our pressure is 30. Let me make sure I got that right. And pressure in this problem is newtons per meter seconds. So you have to put your unit on. And that's all there is to doing that kind of problem. Let's look up here example 2. I didn't write the word problem down. I extrapolated the information. So let me just read it to you. The initial pressure, so that's your initial pressure, is 400 Newton meters per second squared. And the initial temperature is 1200 kelvins. And let's see what else. They tell you that the volume is constant. The volume held constant. So I just wrote V equals constant. That means it's going to be the same in both of these. Then it says, what was the pressure? So that would be your pressure 2, you don't know. If the temperature was decreased to 900 kelvins. Now if they tell you that something is constant, that means we don't really need it in the equation at all. So you can just kind of cross it out and fill in the other things that you know. So we have pressure 1 is 400, temperature 1 is 1200, pressure 2 is what we're looking for, temperature 2 is 900. We can reduce this, so it will go in 3 times. So we would get 900 equals 3 pressure 2, divide both sides by 3, and we would get pressure 2 equals 300. We have to see what our pressure is measured in, and it's newtons per meter seconds. So we just put newtons per meter seconds. And that's all there is to that. Let's quickly do the third problem before my YouTube video runs out of time. Example 3 says the temperature of a quantity of ideal gas was held constant in the experiment. So this time the temperature is held constant. So when we go to write the formula down, we'll just be able to cross out the temperature. The original pressure was 7 atmospheres. The original volume was 42 liters. If the volume was reduced to 10 liters, what was the pressure? So this is the same thing. We're just going to fill in our equation. We'll be able to cross out the temperature part because it's held constant. So let's write down our formula. You will have this memorized by the time you do all your problems. It's not a very difficult equation. So we can cross out the temperatures because it's held constant. We fill in what we know. It would be 7 times 42 equals pressure 2, we don't know, times 10. So we get 280 equals 10, pressure 2. Divide both sides by 10, we get pressure 2 equals 28 Newton meter seconds per second. I think that's what the problem's in. Sometimes pressure is in, this one is actually, whoops. I think this should have been 42, not 40. So that'll change our problem just a little bit here. 7 times 42, we're going to end up getting an answer of 29.4 atmospheres. So you just put a little a there. And I'm not sure what 7 times 42 is, but when you divide it by 10, so it's 294. So when you divide by 10, you get 29.4 atmospheres. And that's it.